Hello and welcome to another All Nation video. This video I'm going to talk more about my engines, and this has been a project that I'd been wanting to do for a very long time, and it's one of those projects where you kind of have to stick with it until the end rather than start and working on it a little bit, stopping, coming back a month later. And so I'd like to share this with my model railroad friends and why this is a little bit different than some of the other videos and the traditional way that we have powered our F units at All Nations. What you see here is our demonstrator locomotive where the side is cut out. And you'll notice that the motor is not mounted high on the platform and connected to one of our tower drives. And what I've done, and something I've wanted to do for a long time, is to see if I could sink a can motor into the fuel tank and make it a direct drive mechanism. And so what I ended up doing was using pretty much a generic can motor, about a 60 millimeter length by 30 millimeters in diameter. And since I had a lot of the parts already created in the 3D CAD program for printing, it was just a matter of making a lot of adjustments, testing and fitting. And so what I'd like to show you by tipping this up a little bit is the top view, where we actually have a double universal joint connected to the motor and to the drive shaft, which is our traditional smaller gearbox units on our axles. Now, these have the covers that I've created on the axle, and the drive runs very smooth and it's very quiet, and there's no binding. It negotiates curves pretty darn good, so I'm very happy with it. The universal joints are very hard to find a double jointed one that is not too long, and I've spent a good number of hours trying to print my own and test them, because over the years I've developed the direct drive for a Jeep that I have using Central Locomotive Works double universal joint in Derlin plastic, or Delrin plastic, I guess you call it. And they work pretty well. Sometimes that plastic would fracture and crack up. You have to replace them. But the hard part about developing a universal joint in 3D printed is that spider between the yokes. And so I just feel more comfortable if it's a machined metal universal joint. And the way to achieve the shortest joint possible in a machine version currently is to use two single jointed universals back to back and use the set screws with a piece of drive rod, 5/32 drive rod, to keep them connected together with the set screws. And then I've created a coupler that connects to the actual drive shaft right here and to the universal joint, which is a transition from a smaller 3 millimeter to the 5/32. a lot of the work involved was to try to reuse what we've created in the past for motor mounts in our units, and to try to find the optimal location. And in this case, I got motors with extended shafts so I could cut them shorter as I needed, and that's always very helpful, because if you get a motor that has a real short shaft, it doesn't give you much opportunity to make different changes. So this motor was actually a little forward on this chassis, but I ended up backing it up 5 millimeters in the fuel tank, and it gave the adequate space between the end of the motor shaft and the power truck. Once this is mounted in the body, the chassis becomes very stiff and flat. The clearance under the fuel tank is a good 2 millimeters, so you're not going to hit any rail heads going through switches on the tank. And again, I deliberately made those tolerances very close, so I could accommodate a drive shaft from the motor as straight on as possible to the power truck. And again, as you can see, this is a single powered truck. The other one is just a dummy truck, coaster if you want to call it. And it appears that it has adequate power to pull just about anything on my layout that I'm concerned with. So I think the whole purpose for doing this is to try to come up with a drive unit that has the fewest number of machine parts so that the cost is more affordable at the end of the day for modelers that are trying to have a really good powered unit. Now, the next step we're going to do is implement this in our brass GP40, where we have a lot longer frame on that engine, and we can probably center the motor in the fuel tank and maybe even double shaft that if we want to power both trucks. And so that's what we've been busy working on, and I may go into detail later on in the video to show how to assemble this, because I am anticipating maybe bringing this out as a kit, and maybe something that's ready to run with the Blomberg trucks, you know, whole 9 yards. So all you need to do is drop it into your engine and replace what you have already in your older models. So hope you enjoyed this video, and thank you for viewing and sharing, and we'll keep you posted on some of the work we're doing currently on some of our other projects.